Now, our main purpose in this chapter to be able to solve 3x3 system of linear equations. So we will have this form. We will convert to the augmented matrix. So then our aim will be like in 2x2. Remember, we just need to make one. Okay, let me just start with the letter C, D. We have to make these guys 0. So whatever with this one, then we will have a unique solution. For 3x3, your aim will be to make under the X these two 0 and these 1 0. So you have kind of, if you want to remember, triangular shape here. If you have all different numbers here, then you will have a unique solution. First, I will go to solve one question with regard to this one. Then we will go and discuss the cases when there are no solutions and when there are infinitely many solutions. So here, first thing to do, what we need to do, we need to convert to the matrix. It will be 1, 4, 11, 7, 9, 4. Then we'll have 1, 6, 17, 1, 4, 8. As you can see, it's easy if they are all 1. What I need to do, my aim is to make these two 0 and also these 1 0. So I just need to subtract the first row from the second and the third for the starter. Let's get started. So what I will do, I will row 2 minus row 1 and replace it in row 2, and also row 3 minus row 1 and replace it in row 3. So let's first write it and see what will happen to the matrix. So the matrix will be the first row no change, 4, 1, 4, 11, 7, and this one will be 0. So I'm just subtracting first row from the second. It will be 2, 6, and 2 again, and then I need to subtract the first row from the third one. It will be 0 here, and it works very fine. It's 4, 4 will be 0, so it's kind of perfect. So I chose the first question. So 8 minus 1 will be minus 3, and 4 minus 1 will be minus 3 again. So here, again, your book advises to make all these diagonal 1, but I'm telling you don't have to do it. So after this one, you need to realize from the third one, the third number corresponds to the z. So this number corresponds to the z variable. So here, from here, it seems that it doesn't seem, it looks like it is, it doesn't look what's in it is minus 3z equals to minus 3. So here, from here, we can see z is 1. Now I found one of the variables. Now I will use second row. From the second row, it says that second row 2y plus 6z equals to 2. I have found already z equals to 1. So 2y plus 6 equals to 2. So from here, y will be minus 2. Now we have found z and y. We'll use the first row to find the x. So x plus 4y plus 11z equals to 7. So I'm using the original equation here. And now I'll replace for z and y. So it will be x plus 4 times minus 2 plus 11 times 1 equals to 7. So from here, x will be minus 8, 11, 3, 4. X will be 4. So your solution is 4, minus 2, and 1. So x equals to 4, y equals to minus 2, and z equals to 1. And now let's go with the cases. Here we have some cases when you do row operations, and if you have, for example, something, when you see this type of problem, when all the variables 0, 0, and you have some number here, or it's also possible that in the second row you may have different combination here. But here, what you need to realize that even you have one of them multiples of another one, and again you have something nonsense here. You have 0, 0 equal to some number. 0 cannot be equal to something. So when you have this case, when you realize it, it means that it's inconsistent and there is no solution. And also, for the infinitely many solution, when one of the equation, one of the lines, one of the rows becomes all 0, 0, okay, there are different combinations. Again, still, you may have possibly for both of them. Oh, okay, for third one, when it's possible, for example, you have x plus y. I'm just giving some random example, 1, and if you multiply all of them by 2, it's just a multiple of 2, and if you multiply the first one by 4, as you can see, they are all multiples of the first one. 4x plus 4y plus 4z, for example, equals to 4. So for this one, you have infinitely many solutions. Actually, what is it? You have one equation, and the other ones are just multiples of them. And if you have this case, when you have 0, 0 in one of the lines, you will have infinitely many solutions. So you will call, for example, one of them t, y will be equal to s, and z will be dependent with the t and s. So let's go with the one example from your book. Yes, the main problem comes when you have with the letters, when you need to analyze it. So let's rewrite it first in a matrix form. So it will be 1, 2, 1, 3, 1, k, and 2, minus 1, 4, and 1, 7, minus 1. So let's read what does the question. Reducer operator to reduce this into row echelon form, so in the triangular form. So let's do again the first thing what we need to do. We need to make these three numbers 0. And after you make them 0, then we need to realize what is happening. If all this part becomes 0, what kind of solutions you will have. Okay, so then we will consider these cases when we have something inconsistent, and if we have infinitely many solutions, or when we have unique solution. So let's do it. As you can see, so I need to make second row 0, the first one. So row 2 minus 2 times row 1, replace it in row 2, and then row 3 minus row 1, replace it in row 3. Let's first make them 2 zeros. Now let's do the row operations. I will write directly. So part A will be 1, okay, no change in the first row, 1, 2, 1, 3, then multiply by 2 the first, subtract from the second, it will be 0, minus 1, minus 4, minus 5, 2, it will be 2 here, and minus 5 here. Then we said subtract the third row from the first one, it will be 0 here, and we will have 5, and then we will have minus 1, minus 2 here, and k minus 3, right? K minus 3. So then here our next goal is to make this one 0, and to make it 0, always use the second row, because it's already 0 here. If you use the first row again, if you do something in the first row, there will be number in x, so you don't want to have it. So in this third step, you always have to use the second row. So what we are going to do, row 2 plus row 3, and change in row 3. We just need to add these two rows. So, and what we will get, no change in the first row, it will remain same. No change in the second row, it will be the same. And the third row, we adding them 0, 0, 0, and k minus 8. Now here we have the first part. It's about okay, we have the echelon form, the triangular form. Now here we have the case for what values of k does the system have no solutions. When it does have no solution, when in part B, when it does have no solutions, when k is different than 8, right? If k is different than 8, then it will be nonsense. 0 equal to some number, so it will have nonsense, inconsistency, like in previous parts. When you have 0, 0 and some number here, then you have inconsistency here. So it's only possible when k is different than 8. So for k different than 8, so any numbers, 10, 11, 100, it will give you inconsistency. Under what condition does the system have infinitely many solutions? So part C, infinitely many solutions when this part also equals to 8. So when k equals to 8, the third row will be 0. It will have infinitely many solutions. Then find the solution in this case. So what we can do, we can call z equals to t. For example, if z is t and z equals to t, then from second I can find it minus 5y plus 2z equals to minus 5. Then I know that it's t already, so y will be minus 5 minus 2t divided by minus 5, so it will give us the y And x will be, I will use the first row, x plus 2y plus z equals to 3. So from here, x will be 3 minus 2 times y is minus 5 minus 2t divided by minus 5. You can simplify it easily. Minus z minus t. If you simplify, then you will have all the variables with respect to t. And here last part, explain why the system will never have a unique solution. Because this part all becomes 0, it won't have any solution. If it were a number here, then we will have a unique solution.